Whoop whoop. Welcome to chapter 13. For those of you who enjoy geometry, you're in for a real treat. Chapter 13, we do a lot of things that tend to bring us back to those days of proofs. Yes, I said the dreaded P word. Just know that, we're not doing formal two-column proofs. Most of what we do in chapter 13 is actually more algebraic. But we have a set of rules, which you guys can see on this first slide. There's a number of rules. All right. As we continue kind of looking at things, we'll just get right into it. A lot of the theorems are on the top. Should already be well known for you guys. Okay, tangent values, remember we determined by y over x. So that should be very clear. Cotangent's the reciprocal of tangent, so that also should be clear. Our reciprocal functions, all right, we know that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So those are going to be nothing new. What is going to be new is our Pythagorean identities. And this is kind of the first one we're going to key in on. If you guys remember our unit circle, okay, whoops. So we have our unit circle. If I were to pick a point on my unit circle and construct my right triangle, if you remember, our coordinates are always cosine, sine, right? And that should be something very clear again. We have our x coordinate and our y coordinate. So cosine's the x value and sine's the y value. Well, if we just do Pythagorean's theorem, sine squared plus cosine squared equals 1 squared. Again, the radius of our unit circle is 1. This first identity should make a lot of sense. Okay. Sorry, where was I going for that? If we look across the board, the other resulting Pythagorean identities, you guys, are just based on the initial one. So if I divide everything by sine, I'm going to get this one on the far side. Cosine over sine is cotangent. If I divide everything by cosine, I'm going to get the one in the middle. Okay, but all of them are based on the same idea. This one is probably one of Ms. Brostrom's and I's favorite, so we're going to use it a ton throughout this chapter. So let's delve into our first problem here. All right. It says find the exact value of the following. Well, if you remember back from chapter 12, we would draw a triangle, we'd label our sides 1 and 4, we'd do Pythagorean's theorem and go from there. Okay? But with chapter 13, we're actually going to use our identities. So given our sine and cosine, we want to pick one of our Pythagorean identities. Okay? And since I'm given cosine looking for sine, I'm going to use cosine squared plus sine squared equals 1. Notice, you guys, how it's written. Cosine squared theta is the exact same thing as cosine of theta squared. You do not want to do this because then it looks like you're squaring the angle. So please be mindful of that going through things. So we're just going to start in the problem here. We are told that our cosine value is 1/4. So we're going to square 1/4. We have sine squared. 1/4 squared is 1 over 16, which means sine squared must be, if I do 1/16, subtract it from 1, I'm going to get 15 over 16. When you square root both sides, you're going to wind up with the sine of theta equals plus or minus square root of 15 over 4. So at this point, the question is, well, which one of those is the correct answer? And that's where this piece comes into play. So it says we want to find sine when our theta is between 3 pi halves and 2 pi. We should know at this point that's an angle in quadrant 4. I know in quadrant 4, my coordinates are always positive x values and negative y values, which means my answer, since I'm looking for sine, must be negative root 15 over 4. If you constructed a triangle based on that idea, labeled your adjacent side 1, your hypotenuse 4, you would actually wind up getting the exact same answer. But again, with chapter 13, we want to use our identities to simplify and solve. So that's kind of the first part of the day, is going to be using Pythagorean identities to solve. The second part of the day is going to be verifying identities. And some of these are where these are going to come into play. If you noticed when graphing, sine and cosine waves look really similar. So if I shift a sine wave, pi halves, it's going to look like a cosine graph. If I shift a cosine graph, it's going to look like a sine graph. Same is true with tangent. Okay. Then keep in mind, we have our negative angle identities. These should also be pretty apparent. But if you have an angle, say theta, and you take the opposite, your y values, if you think about theta versus negative theta, our y values are going to be opposite. And that's why one's positive and one's negative. If we use that same picture with theta and negative theta, if you notice, our x values are actually the same. So if you notice, both of those values are positive cosine. So theta and negative theta are going to have the same cosine value. And then with tangent, if I take a positive angle and a negative angle, just like sine, our values are going to flip. So one's positive and one's negative. So that's where those negative angle identities come from, is our understanding of their position in relation to that reference angle theta. Okay? So, things. Continuing on, the second part of the day, like I said, is going to be, sorry, I think I said verify earlier. What I meant was simplifying expressions. So as we simplify expressions, this is where that chart is going to come into play. Okay? So I encourage you to keep it handy. But we're going to delve into this first problem. And then what you want to do is you want to make this as simple as possible. Okay? And this is where your out-of-the-box thinking comes into play, like from geometry. So we want to make this statement simpler, and I see a tangent squared. So I know that tangent is sine squared over cosine squared. Okay? If I looked at the formula sheet, I would see tangent is sine over cosine, which means tangent squared is sine squared over cosine squared. I also know that cosecant is a reciprocal function. So that is 1 minus sine squared. Then we still have the minus 1. And I know secant squared is also a reciprocal function. So I have 1 over cosine squared. If you want, dividing by a fraction is the same as multiplying by its reciprocal. Okay? Then at this point, we're going to simplify. So we know the signs cancel out. And then all we're going to do is distribute. So I'm going to distribute this cosine through. Sorry, just make sure I change my pen back. So we're going to have cosine squared over cosine squared, which is 1. And then we're going to have minus cosine squared. Okay. Again, that's after we distribute, because this piece is just 1 over cosine squared. So when I multiply by cosine, I get 1. And then we have this minus 1 times cosine squared, which is where the minus cosine squared comes from. Now, if we think about our Pythagorean identities, again, one of our favorite, we know, I'm just going to write this here, cosine squared plus sine squared equals 1. So I know that sine squared is 1 minus cosine squared. And this is a key idea we're going to use a lot. So when you see an expression like 1 minus cosine squared or 1 minus sine squared, we know that 1 minus cosine squared is sine squared. So we're done. So again, today's going to be all about this and simplifying as best you can. The hardest part for people is to just take that first step. And you gotta try something. Can't just stare at a problem because it's not gonna finish itself. So on this next one, again, same idea. You wanna pick something and go. So, well, what do I know about secant? I know secant is 1 over cosine. Sine is pretty simple, so I'm gonna leave that one alone. And then just like before, oh man, 1 minus cosine squared, I've seen that before. I know 1 minus cosine squared is sine squared. Then at that point, we just want to simplify. The sines go away. And if we continue to simplify, we essentially have 1 over cosine theta times sine of theta. I can put that over 1. So I have sine over cosine, which is pretty simplified. But remember, what do I know about sine over cosine? Well, that's how I get my tangent value. So today, so please, please, please keep those formula sheets in mind. Again, those are slides 3 and 4 through my presentation. I don't know how the video is actually going to work out here. But reference those formula sheets. Again, it's listed as helpful hints under the week 5 folder. And the biggest thing is just try something, okay? The path is always there. You just have to pick a route. If you remember back to geometry, there might be 47 ways to solve a proof. You just need to pick one that works, okay? And that's what we're doing here. These aren't proofs. We're just simplifying using those rules on the helpful hint sheet. So your assignments here on the bottom, you guys. Again, keep in mind we're grading for accuracy, so I shouldn't just see, on a problem like this, like part A, I shouldn't just see sine squared. I should actually see your steps on how you get there. That's how you get full credit on these assignments. Basically, this whole chapter is going to be set up like this, you guys. We have no IXL modules. We're just going to be looking at your assignments and the worksheets. So if you have any questions, attend the live session or post to the discussion board. I look forward to hearing from you. Best of luck. We created our own helpful hint sheet. This is in and available for you in the folder. I'll continue to post it each week. We're in chapter 13. But the front of the worksheet has all of the identities we're going to work with during chapter 13. To terms, these formula sheets are going to be super helpful. And on the back side of that formula sheet is a completed unit circle with degrees, radians, and coordinates and tangent values all the way around. So this is going to be super helpful moving forward.